Okay, let's take a look at kites today. I think the best picture of a kite, probably the most clear one, is the one down here. But it is labeled up here, it's just not as dark. So a kite is two consecutive pairs of congruent sides. So these two sides are congruent, and these two sides are congruent. It's got one pair of congruent angles. Those angles are congruent. These angles are not. That looks like it's obtuse, and that looks like it's acute. These angles are congruent. These sides are congruent, and these sides are congruent, meaning for sides to be congruent, they're the same length. For angles to be congruent, they're the same measure. We also know that the diagonals are perpendicular. So let's take a look over here. This is kind of labeled with letters, right? These two are both length B, they're congruent. These are both length C, they're congruent. The diagonals are perpendicular, right? There's a right angle there. The diagonals are D1 and D2. They are not the same length. And one of the diagonals, D1, does actually bisect diagonal D2, but D1 is not split into half, it's just split. So D2 is split into half. Those angles are the same, and those sides are the same, and those sides are the same. Okay, so this is kind of the picture. The area is 1/2 D1, D2, and you'll see that's the same area formula for a square, which is also the same area for a rhombi, but for all rhombi, meaning a rhombus. But that has to be true because it turns out that all squares are kites. All rhombi are also kites. And if you think about the definition of a kite, these are also then true for a square. Again, look back at our flow chart, and I know this can get a little complicated at times, but if you have a kite, you have congruent opposite angles, you have diagonals, one of them gets bisected, you also have diagonals that meet at right angles. Well, boom, down here, a rhombus has that exact same properties. It has 4 congruent sides, but it does have 2 pairs of congruent sides. The diagonals are perpendicular, so all the things that were true for a kite are true for a rhombi, and then are also then true for a square. So a square is a very particular version of a kite. It's got all the kite properties, but it also has 4 congruent sides and 4 congruent angles and all this stuff. A rhombi has all the properties of a kite, but it also has 4 congruent sides, not 4 congruent angles. And then a kite is just kind of a general thing. So it's kind of weird how these quadrilaterals split into trapezoids and kites, and they come back together with a square, or a square literally has everything. It's got all of those properties and all of those properties. So we're really just focusing on generally what a kite looks like. And again, a square is a kite, a rhombus is a kite, but we are today just looking at probably the general version of the kite. And again, if you look in this circle here, the kite circle then does whoom, encompass both a rhombus and the square. Okay, so let's take a look at all the different properties you could know then from a kite. Okay, so let's do some examples. Okay, so how would we prove, let's say I have this coordinate. So this is on some coordinate grid. How would you prove that this is a kite? Again, to prove that's a kite, you want to show me that that length and that length are congruent. And again, you're going to show things are congruent using the Pythagorean theorem. And then you want to show me that that length and that length and that length and that length are congruent. And again, to find the length on a coordinate grid, right, you're just going to use the Pythagorean theorem, and you're going to find numbers for this. So let's say this was like 5 over and 6 up. And you wanted to find that length, you just say that 5 squared plus 6 squared equals c squared, 25, 36, and so then c would be the square root of 51. So you'd want to show me that this is also the square root of 51, okay? And then you could prove to me that it's a kite. So you'd have to actually do the Pythagorean theorem 4 separate times on all these. So you're going to draw little bitty triangles. You're going to do this one, up, you're going to do that one, and you're going to do that one. You're going to do the Pythagorean theorem for all of those guys, find all of their lengths, and then see whether or not it's a kite or not. Okay? Okay, what if I gave you, oh, this is not gonna be the best kite of all time. So let's say I told you this was a kite. So boom, 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 boom. But then I gave you that distance. Actually, what if I told you that that was, let me think, this was 5, and that was 6, and that was 10. Okay, what's the area? So the area formula, you know, is 1/2 d1 d2. You also know that these are perpendicular, not that that matters in this particular case, and you also know that this diagonal does bisect that diagonal. So if that's 5, that's also 5. So our area is 1/2 times d1, we'll call that the 10. Again, if that's 5, that's 5. And then 16. And so we get an area of 80 square inches. So we can prove things are kites. We can find the area of kites. We can necessarily find, oh, let's say I wanted the perimeter of this kite, right? The perimeter of this kite is going to be, I'd have to know this one, this one, this one, and this one. But look, this is its own little Pythagorean theorem in there because we know that's a right angle. So really what you have there is you have a 5 by 6 triangle. And actually I just did 5 squared plus 6 squared up here, which is, that's the square root of 51. And then I could do this triangle, which is 5 by 10. So I could do 5 squared plus 10 squared equals c squared, and that's 125 equals c squared. C equals the square root of 125. Okay, so if I wanted to know the perimeter, I'd have 2 square roots of 51s, 2 square roots of 125s, and if you wanted it exact, this isn't going to work much. You're not going to be able to do anything with that. That one you could break down a little more, and you could say 2 square root of 51 plus 2 times the square root of 125 is going to be 25 times 5. So that's 2 square root of 51, and then square root of 25 is 5. 5 times 2 is 10. But you'd have to stop there, okay, because you couldn't go any further than that. If you wanted to go to decimal, that would be fine. So that would be the perimeter. That would be the area. So we can find perimeter. We can find area. Again, the nice part is that this is 90 degrees. Once you know that's 90 degrees, you can do all sorts of things. So giving me a kite again. I could even give you that this is 6, and I could give you that this, let's say, is like 42 degrees. Since you know that's a right angle, you could find things. So you could find that distance y, and you could find that distance x if you were interested. Again, this is just trig then. So you could say things like cosine of 42 is adjacent over hypotenuse. And then you could type that out. You could say sine of 42 is x over 6, and you could type that out. Okay, so y equals and x equals. Let's go up here and actually type that out quick. So what am I going to do? 6 times cosine of 42. I'm going to get 4.46. And I'm going to get 6 times sine of 42. And I get 4.01. Okay, so I can solve using trig. I can find these. I can use Pythagorean theorem. I can find the area. I can find the perimeter. And there's all sorts of relationships that I can do with this. Okay, hopefully this gets you started on kites.